Hello everyone. In this video, I'm going to go over some questions about binomial experiments and binomial probabilities. So I have a bunch of different problems down here from 1 to 5. And for each question, I'm going to go over some parts to determine whether it's actually a binomial experiment or not. And then if it is, I'm going to go ahead and calculate all the different variables that I need and plug those into the binomial experiment probability formula. Okay. So I'm basically just going to paste this stuff under each of these questions down here, and we'll go through them one at a time. All right. Okay, so let's go ahead and look at the first one here. If you roll a 6-sided die 10 times, what is the probability of rolling a 3, 5 out of the 10 times? So 6-sided die is just like a regular die. It's just die is the singular of dice. So I'm picking it up, I'm rolling it 10 times. What is the probability that it rolls a 3 half of the times, 5 out of 10? Okay, so first, to figure out whether this is a binomial experiment, we need to break it down into trials. So what is the smaller experiment that I'm doing over and over again? I'm rolling a die, right? So rolling a die. And then what outcomes could I consider success and failure in this smaller experiment of a trial? Well, what am I trying to calculate the probability of? That's going to be considered a success. So rolling a 3 is what I want to know the probability of, so I'll call that a success. So success equals roll of 3. Failure then had to be everything else. So 1, 2, 4, 5, or 6. Okay, and then the most important question here is, now that I figured out what trials and successes are the trials identical and independent, meaning the probability of success in any trial does not change based on the outcomes of previous trials? So yes, the die does not remember what it rolled before, so regardless of what I roll in the last trial, the next trial is independent of that. The probability resets to 1 out of 6 again. Okay, so since the answer to that was yes, I'll just put die do not remember. A very mysterious sentence if you found this out of context. Okay, so since the answer was yes, then we're going to just write down the variables, all of their values, and then we're going to chuck them into this formula right here, and then we're not even going to simplify it. We're just going to leave it like that, and we'll call that good enough. Okay? All right, so the number of trials here that I'm interested in is 10 times. That is 10. The number of successes that I'm interested in, what I'm trying to get the probability of, is rolling a 3, 5 of those times. So that's 5. And then since I have 10 trials and I want 5 successes, the number of failures then is 5. Probability of success, this means on any single trial. So a success is rolling a 3, then this is going to be 1 out of 6. Then that means the probability of failure is the opposite, so this will be 5 out of 6. And then finally, I'm just going to chuck all this into the formula. So n, number of trials, number of successes, probability of success raised to the number of successes, probability of failure raised to the number of failures. And that's it. And if you wanted to put that into a calculator, you could do it. All right, next one. If you draw a card from the standard 52 card deck, meaning the standard American deck, 6 times without replacement, what is the probability of getting a heart on 2 of the 6 draws? Okay, so what is a single trial? What am I doing over and over again and looking for a result? I'm drawing a card, right? So this will be drawing a card. And then what can we consider success and failure? It's what I'm trying to calculate the probability of. I'm looking for a heart, so that must be a success. Heart. So then failure is other suits. Oops, other suits. Okay, or just not a heart. Are the trials identical and independent, meaning the probability of success in any trial does not change based on outcomes of previous trials? This is really important, you guys, because that's what this formula is assuming. I'm putting 1/6 into this formula 5 times. I multiplied it in there 5 times because that's how many times I wanted to see that success, and that was the probability every single time, 5 times, of having that be a success. If the probability changes, then I can't just raise that probability to the 5 like this. So I wouldn't be able to use this formula. All right, so already I think I can tell these are not identical trials because I am not replacing the cards. So if I'm not replacing the cards, then I'm drawing out of a different deck each of those 6 times. And whatever happens on the first trial does change the probability of a heart on the second trial. So this is a big old no here. Probability part changes based on results of previous trials. Okay, so it's not a binomial experiment. And that means we do not need to do this stuff down here. Boop, it's gone. Okay, next question. In a certain area, the probability of rain on any given day is 10%. On the day after a rainy day, the probability of rain is 20%. Over 7 consecutive days, what is the probability that it rains on 3 of the 7 days? Okay, so what is a trial? What are we looking for over and over again? What are we randomly doing? It's not exactly random in this case, but we're checking outside every day. Is it raining? So a single trial is check whether it rains on that day. Okay, then what is a success and a failure? What am I trying to get the probability of? Rain. So success is going to be rain. Failure is no rain. Are the trials identical and independent, meaning the probability of success in any trial does not change based on outcomes of previous trials? No. So it says on the day after a rainy day, probability of rain is 20%, but on any given day it is 10%. That means that it changes depending on what the day before was. And we're not even given the probability of what it is. What's the probability of rain on a day after when there was no rain the day before? We don't even have that information, which we would need. So yeah, this is big old no. Rain the day before affects future trials. Okay, so we don't have to do the rest. Yay. All right, next question. In a class of 30 students, 20 students got an A on the test, 5 got a B, 3 got a C, and 2 got a D. If you draw 4 random tests with replacement and check the grade, what is the probability that 3 of the 4 tests have an A? Okay, so what is a single trial? What am I doing over and over? Draw a test from the, not deck exactly, but the stack of tests. And what is considered success and failure? What am I looking for? I'm looking for an A. So success will be A. Failure will be not A. Are the trials identical and independent, meaning the probability of success in any trial does not change based on outcomes of previous trials? Because I'm doing this with replacement, yes, it is the same stack of tests every time, and that means the probability will stay the same. Yes, because we draw with replacement. Okay, so now we need to do these questions. How many trials am I doing? I'm drawing 4 tests, so this is 4. How many successes are there? How many am I looking for? Yeah, 3 out of the 4 is where I want to see A's. How many failures am I looking for is 1. Probability of success, so now is where I need this like extra numbers information here. So 2/3 of the students, 20 out of 30, got an A. So this will be 2/3. That means probability of failure is going to be the opposite, so 1/3. And now I'm ready to chuck everything into the formula. So number of trials, choose number of successes, times probability of success raised to the number of successes, times probability of failure raised to the number of failures. And that is it. Make sure you don't put a line between these two numbers. This is not a fraction. This is a very simple notation for a very complex formula that involves factorials. Okay, last question. An archer shoots arrows into the target shown at right. Assume that the archer always hits somewhere on the target, and the likelihood of every point on the target is the same each time. The archer shoots 8 arrows. What is the probability that half of the 8 arrows hit the center orange region? Okay, so what is a single trial? What are we doing over and over again? Shooting arrows. Okay, or a single trial, I guess, would be shooting 1 arrow. Okay, what outcomes are considered success and failure? So I'm looking for them to hit the center. The success will be get orange. Failure is not orange. Are the trials identical and independent, meaning the probability of success in any trial does not change based on outcomes of previous trials? Let's see here. It always hits somewhere. likelihood of every point is the same each time. Yeah, this is the important part here. If the likelihood of every point on the target is the same each time, that means they are independent. Yes. Okay, since it's a yes, we'll go ahead and fill in the variables. Number of trials is I'm shooting 8 arrows. Number of successes I'm looking for is half of the 8 arrows, so that's going to be 4. That means the other half are going to be failures. Probability of success, so here I have to actually use the fact that every region has the same likelihood. So this is 25 little subsquares, and one of them is the orange one. So this is only a 1 out of 25 probability of success. That means the rest of the probability, 24 out of 25, is failure. And now I just throw everything into the formula. N, R, P, R again, 1 minus P, and number of failures, 4 again. And that is it. Hope it makes sense. See you in class.